Hello all, welcome back to our channel. In the previous sections, we had seen about GD&T, symbols, and some of the applications. Okay, so in order to brief it, what is GD&T? It is nothing but geometric dimensioning and tolerance. So without tolerance or without dimensions, we cannot able to manufacture even a single component. Example, you take a cap. So this cap, in order to manufacture this cap, we need some particular dimensions like diameter and length of the cap and what is the shape of the cap. Without knowing all these things, we can't able to manufacture this cap. In the same way, we can't able to manufacture a component with exact dimensions. So there should be some set of tolerances. Tolerance means plus or minus. We indicate as plus or minus. So that particular size, whatever the size we are giving for this cap, that should be within the set of limit zone. That limits we call as a tolerance. That means the maximum diameter and the minimum diameter wherein this cap can be produced. We have to give that particular limits and tolerances. That limit we have to give for particular dimension. Then only it is possible to make this cap into the pen. So geometric dimensioning is nothing but it is the application of dimension and tolerances for a particular component to get manufactured or produced perfectly, right? And coming to the symbols, as I said, it is the limits or we call as a tolerances. In order to set these limits and in order to set that part into the mating component, we need some set of symbols or we follow some set of symbols in GD&T. There will be 14 set of symbols, namely flatness, circularity, profile, cylindricity, straightness, runout, total runout. So there will be 14 symbols wherein we have to use these symbols with respect to our application. Okay, so there will be 14 symbols which are used in our GD&T concept. And where is this GD&T applied? As I said earlier, this GD&T is applied for assembling of components and for manufacturing of any component, right? So this is what we explained or we have seen in the previous sections, and in present section we will see about general dimensioning and geometric dimensioning. So what is the difference between a general dimensioning and geometrical dimensioning? So general dimensioning, as I said, it is just a normal dimensioning of a part. Just only the normal dimensioning. That means some value plus or minus tall. Tall is nothing but limit or zone. So with this help of this dimension and tolerance, we can manufacture a part. A part, not an assembly, it is just a part. So that is called as a general dimensioning. When it comes to geometric dimensioning, in order to assemble a part like this, we need some set of symbols. With the help of those symbols, we can able to assemble the component. Without this geometric dimensioning, we can't assemble the component perfectly. We can assemble, but it will be of a different shapes. It can be like this, it can be like this, inclined, or some 90 degrees, or else it won't fit into it, just it will be like this. But if we apply geometric dimensioning and tolerancing in this concept, we can assemble this component perfectly without any deviation. So that is the use of geometric dimension, and this is the difference between a general dimension and geometric dimension. Just we will see a small example of it. So we will take a shaft and a whole concept. Okay. Assume that shaft is like this. It is having a diameter of something around, say, 50. As I said, in order to manufacture this shaft, what are all the dimensions we need? We need diameter of the shaft and total length of the shaft. If we have these two dimensions, we can able to manufacture the part. So this we call as a general dimension. It's a general dimension. As usual, there will be some plus or minus tall for each and every dimension. So how can we decide this tall means? Based on the application of the component, we have to decide this tolerance. So this tolerance should match with the mating component tolerance, or else the part get failed and we can't able to use that part. So this is what the concept of general dimension. See here, diameter 50, (0.2) and 0.1. I have given this as an example of diameter 50 shaft with tolerance of 0.2 and 0.1. This is called as a upper tolerance limit, and this is called as a lower tolerance limit, or upper tolerance zone and lower tolerance zone. What does it indicate means this shaft can go up to 50.2 diameter, and it can go below up to 49.9. So this is called as a tolerance zone. So while making a part, as I said, we can't able to manufacture exactly 50 diameter. So there should be some tolerance zone. That is what this tolerance zone. I have set the tolerance zone as 0.2 and 0.1. So this shaft can able to produce, or it can come up to diameter 50.2 and it can go below 49.9, or it can go up to 50.2. Right? So this is the shaft concept. When it comes to hole, this is the hole. This is having a diameter of 50. So how I have to decide tolerance for this hole? So maximum diameter of the shaft is 50.2 and minimum diameter is 49.9. So this shaft should go into the hole. This is the hole. How I have to decide the tolerance means normal diameter is 50. This is the maximum diameter of the shaft. That means hole should have a tolerance of 0.3 maximum, and it can be a 0, but it should not go beyond this one. Maximum should not go beyond this one and minimum should not go beyond that limit. Okay, so in this case the maximum diameter of the hole will be diameter 50.3 and minimum diameter will be 50. Or it's up to us. If you keep 0.1 here, minimum will be 49.9. So it will be a tight fit. So when the hole or shaft is going to assemble with the minimum concept, it is going to get a tight fit without any tolerancing. So when it goes to the maximum, there is a tolerance limit of 0.1. So maximum concept is this one. Shaft is going to get manufactured at diameter 50.2. Example this one. And hole, take it as a whole. This whole diameter is going to manufacture with a maximum of 50.3, wherein it will fit into it. Right? So this is the concept of assembling of two components with respect to tolerance. In the same way, see here. So this is having a diameter of 50.3 and this is having a diameter of 50.2 including tolerances. Okay, so this is how where we have to consider or where we have to decide the tolerance of a particular component when it is going for assembly. Okay, in the next section we will see the application of GD&T with respect to these concepts. As I said, in order to assemble this component, this one here we have not assembled it. We made it ready for assembly. This component is not assembled perfectly now. we have made this component to get ready for the assembly. See, as I said earlier, this shaft can assemble like this, or it can assemble like this, some inclination. So this is not a perfect assembly. In order to get the perfect assembly, we need to apply some set of geometric symbols to get the part a perfect assembly. Like this. Why do we need a GD&T for assembly? Why? Because after assembly, we need some set of joining process. Joining process is nothing but we are making this component into it. We need some set of operations to perform at this joining process. Example is welding. So to fix that part, we need to apply some set of welding procedures so that this part cannot have any movement after the assembly. If the part is having any movement after the assembly, then it's of no use in making that part. We can't use that part in future, because based on the load applications, if there is any movement of these two components, the mating component is going to get failed because of this movement. In order to arrest this movement, we have to apply some welding procedures. In order to apply welding procedures, we have to use some set of symbols to arrest the component perfectly. Without arresting this component in a perfect stage, we can't weld this. So by using this set of symbols, like 14 symbols, we won't use all the 14 symbols in one concept. Depending on the application and depending on the shape of the part and depending on the profile of the part, we are going to apply some set of symbols to arrest the component, and that set of symbols we are going to use in GD&T. Right? Finally, what I conclude is, in order to assemble a component, we use some set of symbols which are applied in GD&T to fix the part for welding. So this GD&T we'll see in the next section. Right? I hope you understand the concept of GD&T and the difference between general dimensioning and geometric dimensioning. So in the next section, we will see what is the application of these symbols with respect to assembling of components. And there are a lot more to discuss, like maximum material conditions, virtual conditions, flatness, where we are going to use the flatness tolerances, where we are going to use all the 14 symbols, where we are going to use the circularity, cylindricity, profile, position, how to decide whether it is a position tolerance or a profile tolerance. So all these things one by one we can able to see in the coming up sections. I hope you understand and we'll meet in the next section. Thanks a lot.